Hello, welcome back to another coding session with our language Bangalang, our low-level explicit procedural compiled language that runs on the CPU and the GPU. We're going through a list of features that I wanted to still add. I feel like the core of the language is sound, but there's a few more features that I want in here before I can be happy to use it on other projects. We've got a couple of things actually that I want to just tidy up from the last session. The first is that somehow I managed to misspell playground, not only there, but also over here. Playground. I'm not sure how I managed to make the same typo everywhere, but somehow I did. So let's get rid of these playground files. Okay, that tidies that up. And then also I wanted to just like sort of take this little thing and make a test from it. So let's make another general test. Anonymous proc. So we'll sort of take this and then we'll do like more of a test style. You know, we always do var0. And I did think of like a more, instead of having this whole struct here, we can actually just do proc at stack equals do, and then just call var0. And we'll put a debug assert in here. I mean, I don't really know what to assert. I guess we can take in something. Param0 can be like just a U8. And then we'll just verify that that equals 2 or something, and then we'll pass 2. I don't know. Something like that. So what's going on with this at stack stuff? So we have this procedure that we're declaring and we're allocating it on the stack, which effectively means that this variable is going to be a stack pointer. Not a stack pointer, a procedure pointer. It's going to be a pointer to a procedure which is on the stack. Which means that this is still going to need to be an anonymous procedure. Only if it's a static procedure, then it will be, it will have a proper name in the assembly. So this is testing an anonymous proc, just a little bit of a simpler example. So let's just run the tests to make sure that that's all good. And while that's going, let's switch over to something a little more loopy. So let's go for, what would a for loop be? Like a ranged for loop. That's what we want to do. So we're going to do something like for index in 0.10. You know, something like that. And then we'll say like do strings.println strings dot I to A. Oh, we can see that Xcode was Xcode 0, so that's all good. We're going to need a buffer. I'll just say 8 bytes. And we pass index in. So, just separate that out. This is the main thing that we're wanting to do here. So, for index in this range, do this, which is just going to print out the index. Or let's say value, maybe that's a little bit clearer actually, value. And these are the values. So that's what I want to be able to do. I also actually want to be able to do, like if we say foo is a vec4, for example, with some values, then we should be able to say for value in foo, print out the value. So So for an array or a slice, we should be able to just put the array or slice here and it'll loop through every value in it. But first we're going to tackle this one. I think this is the simpler of the two. And yeah, let's see how that goes. I also kind of like, for consistency, to use this as a range operator. Like currently, you know, this is a slice. If I wanted to have, you know, from the start to index 4, I would do this. I'm thinking about changing that to this, because this is like the range. And we're sort of declaring a range in here. So it could be like 2 to 4. I don't know. Now that I print that out, it doesn't look that nice. But I kind of like the consistency with this. And I don't know why I would use a colon here. So food for thought anyway. Maybe we won't change it here. But let's put it in the cleanup. Switch slice range operator from colon to ... question mark. I'll put it in my question mark stuff. It's the stuff I'm not sure if I want to do. Okay, so let's get this working. What do we need to do first is have a new token. I think, yeah, we need to go into tokens and we need a period, I guess it's a double period. And then we need to go into tokenization. Then we can get rid of that. We can go into tokenization and we can say that period is 2 periods. So now we should tokenize fine. Then in parsing, I think what I'm going to do is I'm actually going to split this out. So this 4 I'm going to call a basic 4. And I think I thought about this a bit, and I think because the syntax is quite different, if I use the same type for both of them, then trying later on in type checking and then generation to figure out which of these two we're talking about will get quite difficult. Like just from looking at the child nodes alone, it's going to get really hard. So I think instead we're going to have a basic for statement, and then I'm going to make another one which is a ranged for statement. So here we're talking about the basic for, and we'll make a ranged for, and we also need to make just a for. So, and that would be something like this. Where we try one, we try another, and then we pick the best one. So in this case, it would be, we would try the basic for. So I'll call this the basic stream, basic node, basic, okay. And then we'll try the ranged for. Which we haven't defined yet. And we'll check the basic stream and range stream to see which one parsed the most. And whichever one parsed the most is the winner. Do we care about, hey, Mr. Light, which one we prefer? I feel like the ranged for is more like, kind of more restrictive because it requires this keyword right here. So it's really like, if we parsed one of these correctly, then we definitely didn't parse a basic for. So I kind of like the idea of preferring the ranged one. So if the ranged one was longest, then we're going to go with that. Otherwise, I mean, I think it's not that important which one we chose, but Otherwise, we get the basic stream. The reason I'm saying this is because, like, I'm saying that if the range stream, basically here I'm saying if when we parse the ranged for, we managed to parse the most tokens before an error occurred, then obviously we use the range stream, and otherwise we use the basic stream. But the tiebreaker is kind of like, what if they both parsed the same amount of stuff? Then we're going with the ranged first. So it's kind of like we're saying, hey, I think you were doing a ranged one. Actually, so maybe it's better, actually, now that I say this out loud, to assume basic. Assume they're doing a basic one, and unless it really stands out that they're doing, because this is kind of a special one, right? Yeah, okay, let's do that. Parse ranged for. So this is the ranged for. So this is the new parsing that we need to figure out. I guess all of this means that we're making a grammar change, right? So we should probably sort that out. So we have like basic for statement, ranged for statement, and then for statement, which is the for statement is a basic for statement, you can probably guess, or a ranged for statement. That's what a for statement is, either of those. So the basic one is exactly what it was before, but now the ranged one, we'll just handle the first case to start with. So the ranged one would be for, and I'm just going to keep it really simple to start with. So I'm just going to say identifier. No, well, it should always be an identifier here. But when we get into this, like there might be later on, I don't think we'll handle it now, but you should be able to do a pointer to the element, because otherwise this is going to be a copy. But we won't handle that right now. Let's go. Put a note for that. Okay. So let's go back to the grammar. So it's for identifier, and then the next keyword is in. And don't need that. And then we have right-hand side expression. And then we have the token ... and then a right-hand side expression, another right-hand side expression, and then a scope. Does that sound right? Identifier, in, right-hand side expression, ... right-hand side expression, scope. Yes. Our in needs to be a nice color. This is very important. Which actually reminds me that we do need to add it as a keyword. So put this here. So now it's a keyword. Cool. All right. So finally, yes, parsing the ranged for. So first we have a keyword. Then we want to parse an identifier. I did actually want to do some cleanup here. Because this, I feel like it's more like a general kind of to node type thing. Do we have a util in here? Maybe it's an AST. Yeah, we have this map here, which is to node type. And I want to say to node, which converts a token to a node. So we get the token in, and I think we just return like this, right? But we use our toNode type on the token type. And I think we need to add identifier in here. I don't think it exists yet. Identifier token becomes identifier node. So then we don't need this parse identifier business. Instead, we will do token as an identifier token, and then ast.toNode token, like that. That's the same. I guess that needs to be declared. And this one is a member, like so. And I kind of actually, I think part of what I wanted to look at here was, where were we? So we parse identifier we don't need anymore. That's right, it was an ASTU tool. So where do we use toNode type? Because maybe we can just use this new toNode now. See, look, this is basically doing toNode. So operator node is just ast.toNode from the token. Which I think should probably be, let's call it operator token. Here's another operator one, which I think is the same. And here, yeah, we do that separately. I don't know why, but I think we can just say toNode op, and here it's another operator. toNode operator token. Yeah, that's a little bit cleaner. Okay, enough of that aside. Yeah, the reason for that was then we need to do this here, don't we? Do we still have... So this is kind of like the... I'm going to call it the element token, element node. You know, that's this here. I'm going to call it the element. Then we need to have the keyword in. Then we have a start expression node, I will call it, which is this 0. Then we will have the token period, then an end expression, and then a scope. And I believe that's it. I think that's our range 4. Parsed. So now for tokenization, not tokenization, for type checking, when we go to statements, Do we want to have like a type check for? Yeah, so let's do that and do basic and ranged. And this one I'm going to rename to basic. This one I'm going to make a ranged one. So type check basic for, type check ranged for. I don't really think there's a point in actually, I think it's probably easier just to do this. And then we'll go basic and ranged like that. And we'll get rid of the original for. Yeah, I'm gonna handle both of the for statements like that. So the basic for is just the same as it was. The ranged for is where things get interesting. Yeah, I guess that stays the same. The reason we have this kind of pattern is because we have like variable amounts of children. But at least right now, we always have 4 children. Which actually reminds me, we didn't actually add this one. That should be a child. Okay. So this is the element node. This one's the start expression node. This one's the end expression node. And this one is the scope node. And what I want to do, because I feel like this ranged for loop is kind of a bit of syntactic sugar. I'm kind of putting it in that category. I feel like we can, in the AST, I feel like we can translate it into a basic for loop and then type check that basic for loop. And then when we get to generation, it'll just do, generation already knows how to do a basic for loop. That's kind of what I'm thinking right now. I don't know if that's the best approach, but that's, I think it'll be all right. So with basic, I call it basic for node. So the type equals basic for statement. Then we want to create a, what do we call it in the basic for? We don't have naming there, but in parsing, basic for, so we have the pre-declaration node. Which is a declaration, makes sense. So that's an assignment statement. And we're going to append to the children of that. So what's the left-hand side of this statement? Well, the left-hand side is the element, right? We're declaring that this value, and we should initialize it with this. Yeah, I think that's right. Okay. So element node goes on the left-hand side. Then we have our assignment. And then the right-hand side is the start expression. That's what we assign to it. So that's our pre-declaration. And we add that to our basic for node. Next one is the expression node. So that's telling us whether to stay in the loop or whether to exit at each iteration. That is a expression. So we don't have an expression node, it would be a less than, I think, because we want to each iteration, we want to check that this is less than this. So less than, left-hand side is element node. Right-hand side is end expression node. So while the element node, while this is less than the end expression. Yeah, that makes sense. So that's our expression node. I think I can like cut all this stuff out. Oh, type check scope we should do. No, I think actually we won't do that because then at the end we say we replace node with the basic for node, and then I want to do type check basic for. Where's our context go? Like this? Yeah. So we replace our current node with the basic for loop, and then we type check a basic for loop. So we do need to append to the basic for node. Our scope node needs to actually get added as well. Okay, so this third one is the post assignment node. That's where we increment this value. So this value, I think it's just the value plus equals 1, right? Each iteration of the loop, we add 1 to this. I think that's it. So it's also an assignment statement. Left-hand side is the element node. It's add assign, and the right-hand side is the, I guess, the number literal 1, because we're adding 1. So it's value plus equals 1. Value plus equals 1 is what we do each iteration of the loop. I think that looks good. And then in generation, when we go to a statement, I think we basically just look for basic for, because all the ranged fors have been converted to basic fors. So that's the only one we need to handle. We should probably rename it though. Generate basic for. Like so. I think that should kind of work. Parse ranged for. We don't have a procedure called that. Parse ranged for. Oh, I think we need to have the context. Yeah, that's what it was. Okay. Here with for, so I guess this is generation. So again, we only care about basic for. And what's this? Our list of statements needs to have basic for and ranged for. Those are all our statement nodes. Let's try that. I was thinking about it a long time. Oh, because we're running tests. Really, I want to run the playground. I guess this will just, okay, We didn't break anything, not yet. Okay, invalid token period. Expected period but got keyword. Playground 6. 6. So when we're parsing a range 4, we get to here. I'll put a breakpoint there because after the in means we're definitely looking at a range 4. And there seems to be something wrong in here. So if I step in, the first primary node is a number literal 10. Makes sense. Oh, wait. But it's this. No, wait. Shouldn't it do 0? Oh, you can have periods in numbers because you can have decimal places. That's probably messing with things. Yeah, so this is the number, and it's going through and making sure that it's looking for digits or periods if there hasn't been a period already. So it's saying that this is a valid character if we haven't found a period yet. But I don't want it to catch my period. So I think I might say like the next character can be a period, but if the period, but if there's also a second period, so this is the offset, then that's not valid. So if we haven't found a period yet, the next character is a period, and the next character is not a period, then we're good. So that should avoid interfering with double periods. Let's just skip past this. The value has not been declared. Well, we get a different error. Value has not been declared. So this is our declaration. But for something to be a declaration, we need to have type information on the left-hand side. So we need to add some sort of type node here. But what type is it? I guess the type comes from here. I mean, in this case, these are just numbers. They don't have a type. But we can't really give this a type. It needs to get it from here. So let's get rid of this, get rid of some of the stuff that's not necessary anymore. So I think I'm going to give it a none type. So because it has a type, even though it's none, then my type checker will consider it a declaration. So it won't say, hey, what's value? Because we're declaring value now. But it will require the type information from here, which honestly I don't think it's going to get. So probably now it's going to say cannot determine type. Yeah, could not determine type. Somehow can we provide like a default type to these numbers? It's kind of hard because at this point we don't know the type information. We could do like a type check of this node to apply type information, but the problem at the moment is that if we type check this, then we type check this, which includes this, we do a double type check of it, and I don't really care that it's a little bit inefficient. The problem is that the way my type checking works at the moment is it assumes that it has not been type checked yet, and it just appends types. So we're going to end up double appending types, and I think that's going to cause trouble. So it's kind of a complicated thing. I think for now, I'm just going to cast this, like explicitly give this a type, which should then get passed on to value. Yeah, see, look, here we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's looped through from 0. So we're excluding this value, which is what I wanted. And we printed them out. So it worked with this annoying cast. So do not require casts for ranged 4s. But it works. We have to do, we have to do an annoying cast, but it works. That's pretty cool. So we were able to translate this to a regular for loop and execute it. Next challenge is to get this one working. So in this case, we don't have expression ... expression. We just have expression. So if we go to, let's start at the start. Our grammar, range base 4. Did I even check to see that it looked right? Ranged 4 identifier in right-hand side expression, ... right-hand side expression, scope. Looks good. So now I think we're going to say that this part is optional. Yeah, so this line here, no, this line here. So we can see that the ... right-hand side expression part, that's optional. So it could just be for identifier in right-hand side expression, scope. That's what we have here. This is type checking. Let's go to parsing. Ranged 4 parsing. So basically we said this part is optional. So if peak token dot type equals period, then we do this. Now, that wasn't so hard to change parsing. Type checking, however, we're going to have to, I'm going to try and make a for loop, a basic for loop again, but it's going to need to be quite different. So let's say if the length of our children is 3, then we're going to do this, the new style that we haven't done yet. Otherwise it must be 4. Yeah, I'll put this in here. Otherwise it must be 4, and we do it that way. So if there's 3, that means there's no end expression node. And how do we do our nodes? So our pre-declaration so this value here, we kind of need to reassign this during every iteration of the loop. So it's like we kind of need to convert it so that we have, you know, a line here, value equals foo current index. Right, we kind of need to have this. I mean, we can keep track of the index, same as we do in this one. And then I think we have to have this line here, because just with a regular basic for loop, I don't think we can keep track, I don't think we can update this the way we want to. So we have to have an extra statement in here. So we can inject that statement, that's okay. So then actually what we're keeping track of in the basic, this stuff up here in the basic for is the index. Which reminds me, maybe some of this we can get to, but I want to make notes of it anyway. Because like in Odin, you can go like this, and then you can have access to the index also. And because I just said we're keeping track of the index, it's probably not hard to do. Okay, so let's have a go at this. So we're going to need to create an index variable, and that variable should not clash with other variables. So the index name, let's go format a printf. Yuck. Where are we? Up here. I think I added the next index, didn't I? Yes, fantastic. So this is the, let's call it the index. I don't want to call it the index. Oh, let's call it the for index. Yeah, that's good. So the index name is like, no, usually I use square brackets, right? Like index underscore %i. That's the name of that variable. So because we have square brackets, it cannot conflict with other variable names. And then I might go like, even make a node. So we have an identifier where the value is index name. We might even be able to just go like this, now that I think about it, because maybe we only need the node. Let's try that. So now the pre-declaration is setting that, which we can say is an I64. It's the same type as a length. So we have this index type node, and I have been meaning, I think it would be nice semantically to have a length type node also, because I think some places we use this, it's actually a length. Yes, see, we're copying a length into it. So I think it makes kind of, I think it's a bit nicer to call it a length. And here slice length location, so that's also a length. Length register, this is all length stuff. So here we're talking about indexes, I think. Yeah, here it's all indexes. Okay. So if we get back to where we were, our ranged for, which I'm realizing now is in type checking, and that what we just looked at was in generation. So maybe I'll steal this length type node and just put that in here. That doesn't mean to be dereferenced. Okay, so our pre-declaration is setting this variable of this type to, in this case, we can set it to 0. We're starting at 0. So we'll set it to the number literal 0. Okay. Expression. While that index variable is less than the length of this start expression node. So the length of this is the start expression node. So how do we do that? I guess we create an identifier. I think it'd be easier to copy this. Create the identifier length, and then the child of that, because this is how we structure our AST, is the start expression node. So now we're saying, you know, the right-hand side is the length of the start expression node. Okay, because the member in the tree is above the thing that it's a member of. Okay, post assignment, and we also need to get the scope. Post assignment. So what do we do at the end of every iteration? We need to increment the index. So now we increment the index. Cool. And then the extra thing that I said we need to do, maybe before we add the scope in, is we need to, I think it's inject at the children of the scope node position 0. So we're saying the first statement in the scope is going to be an assignment, another assignment. It's like the element assignment node. Like so. So it's an assignment, just a straight up assignment where the right hand side is the index. Oh. Yeah, the right hand side is an index node. Index nodes have 2 children. So so the first child of the index is the thing that's being indexed, which is index node. No. Which is start expression node. That's the thing we're indexing into. This is our array that we're indexing into. And the second one is the index, which is this guy. And then the left-hand side should not be index, it should be it should be our element node, which I don't think we've used yet. Right? Yeah, we couldn't use the element node yet. So this is how we're actually getting something into our element node, so then it can be used within the for loop. I think that's correct. And I think that's all we need to do, and then everything else should sort itself out. Index 0 is not a member of type array. No, well, it shouldn't be. I must have got this. Well, let's comment this out. I'm not sure if this is the issue. No. Value has not been declared. So maybe it was here. I think this should be, just based on where I've put it, yeah, it should be the child of children 1. Okay, value has not been declared. Okay. I think that might be because this is basically the declaration of value. But like I said before, when we did the other one, when we do a declaration, we need to give it a type. And in this case, we can definitely just give it a none type, because it will take the type from the result of this right-hand side. I'm just trying to think now whether, yeah, I think we'll just give it a none type. I think that's a nice, easy way to do it. Okay, types F32 and I64 are incompatible on line 10. I think that's legit, because I2A at the moment just takes I64, so. All right, so we got 0 to 9, that's our original loop, and then 2, 4, 6, 8, 2, 4, 6, 8. So that loop worked also. So we have these two nice range-based for loops. Make index available. I'm curious because to make index available here, I think could be trickier. So I'm curious if I go to Odin and I look at the for loop. Here we go, for statement, range-based for loop. I wonder what he did. Second index value can be added. String array slides. So okay, so for this kind of loop, this is the first one that we did. It doesn't seem like he provides an index. It's more for like when you're indexing into some array or whatever. So I'm kind of happy about that because that makes it like more legit that I could do this. Is that going to be difficult though to, it's just the way I handle my nodes, because now that's going to make it so that this has 4 children, 1, 2, 3, 4, as well as this having 4 children. And then I kind of have to look at the children and see like which one is like, what kind of loop are we trying to do? And so I think I need to be a bit smarter about how I arrange my nodes. And I'm not going to bother doing that right now because we're late in the video. I think that's a bit too much to do right now. The cast also. The pointer. Yeah, I think all the stuff we're going to kind of leave because we're pretty late in the game here. I'm just wondering if there's anything like here that we can try. Underscore var not saved. I feel like that's a reasonably easy one. I'm just kind of not sure whether it's like very important right now. Oh, there was this one actually. C string is alias of byte pointer. I kind of want to do that. All right, let's try that. Let's do a whip commit. Let me just check OpenGL again. Panic out of bounds. We broke something. Okay. Let's go back here. What did we break? Let's try the tests. And let's open OpenGL. What did we break? This is where we comment out lots of code. Okay, the tests all succeed. Oops. But if I run OpenGL, like that is fine. If I just init the window, there seems to be no issue. If I init boomstick, oh, now we get panic out of bounds. So let's have a look at that. Boomstick, here is our init. So if we cut out this for loop, we still get panic out of bounds. So if I cut out 3 start, we still get panic out of bounds. So if I cut out this, we don't get panic out of bounds. So somewhere in here, we're getting a panic out of bounds. I think it's down the bottom. Get CPU core count. So if I just cut out this loop, okay, we're not getting a panic out of bounds. We're narrowing it down. So if I have the for loop there, but just not the contents, we're all good. Maybe if I include the if, we're all good. So maybe this line. Okay, now we get panic out of bounds. So somewhere where it's doing this indexing, that's not happy. So let's print some things out. If we make a buffer of 8 bytes and we print out this, I'm just going to prefix it with what it is. So that's this, I call it the start. The end is this. And then I'll say the length of buffer, that's what we're indexing into. Like that. Let's check all those. Where's my print? That's a bit weird. Okay. Panic index out of bounds? What? So if I do that, does it say panic out of bounds? And if I take off the +1, take off the index, what? Okay. I'm a little bit like taken aback here. I don't know what the hell's going on. But if that's what's causing it, let's just print index and print that. Is it going to print those? We didn't get an error then? Oh, wait a minute. Because it was like that, right? And then it had the panic. Yeah. And if I take that out, it doesn't panic, right? Right. So if I add that in, it does panic. If I put that above, it doesn't panic, but it doesn't print anything out. Okay, let's have a look at the assembly for this. Oh, it's not in the playground, it's in OpenGL. We're converting to a different size or something. Yeah. Okay. So we're getting the CPU core count. And let's just reduce the amount of code in here. But we don't get a panic then. This seems really like, is it just random? Now it panics. Sometimes it doesn't panic. I think we've got some weird memory corruption potentially that we've managed to do. Even though we only use basic for loops here, so like what did we change even? We changed these nodes, how they get parsed. I guess I could have screwed something up there, but there's definitely some like randomness to this, which I did not think about before. So if we did this and just run it a few times, it seems like it never triggers. But when we're like this, it does sometimes. But not every time? I don't know. So let's look inside the innermost. We're in this procedure, let's look in the innermost if. So we have, well, it's the only if. So where's the if? There's the for loop, here's the if. And if we don't have any content within the if, it's not going to trigger, right? Oh, it does sometimes. So it could be this. I mean, that's the only place where we were indexing now, right? There's no indexing in here except for there. And our CPU cores. So if it's intermittent, it's possible that it was working sometimes before. From index, which is less than read count minus this length. So if it's less than read count minus that length, then index plus that length. Should be legit, unless read count is sometimes messed up. So let's have a look at read count. Zero. Read count. Why would read count be zero? Linux.read. Oh, I did mess this up. How did I not see this last time? And I do have a note that we need, like if there's a return type here, we need to check that there are returns, you know, that it does return. Get time of day, that doesn't need a return because it returns in here. Wow, okay. I hope there's nowhere else that I messed up like that. What about in threading? I feel like there was a lot of them in here. No, not those ones. These they don't have return values. Okay, I'm not sure if there's anywhere else that I screwed up, but now I should get a proper read count. Yeah, read count 1,000. Okay, I wasn't returning. That's definitely something we need to clean up. So boomstick threading, we should be able to uncomment everything now. It is uncommented. Then we should be able to go back to here. And hopefully it runs. Okay. Wow, thank God. Figured that out. Let's just run the test one more time. I was worried there. I was worried. So maybe we can turn these into tests also. We have a bunch of for loop tests. If for expression scope, for break, for continue. So let's say for ranged dot dot. Okay, good, exit 0, good. For range dot dot is like this guy. So we always use like these names, it seems like var 0. I don't know what to do, eh? Yeah, I don't know that we can really do any assertions of this. Like, how do we do it for other for loops? We declare something outside. Oh yeah, for some reason I was thinking that we wouldn't be able to do that. So if we say some, yeah, we do some, well, yeah, we should just copy this, shouldn't we? 10 down to 0. Oh, we can't, oh, that's a good point. We can't go backwards. So we go 0 to 10, but it's a sum, so it should still work, right? And then we just do sum plus equals value, and then we assert the sum for ranged array. I guess we should do for ranged slice. Call it numbers. So for ranged array should be sum, and then we go values I64 10, and then we'll go so this is not actually going to work properly. So we actually want to go, because it's while value is greater than 0. So I think we actually want to go like 1 to 11. So that'll actually sum 1 to 10. So now we have 1 to 10, and we can go value and values, and that should work. And then for the slice one, I just wanted to say make a slice of it and do the for loop over that. Okay, let's try those tests. Not looking good. Okay. Yeah, they all failed. Is it 1 to 10? So we start at 10. Oh, this is with the continue, it was 50. So what is it normally? 50, 55? 55. Let's try that. Fingers crossed. Well, these general tests normally happen pretty early on. Like the order is not deterministic, but the general tests are the first things that I run. So yeah, okay, we're all good. We're all good. Okay, happy. Was there something else I was going to, that's right, we're going to do C string as alias. We're at 117 now. I think we'll leave it. I think we'll leave it because we're far enough along. Okay, so we've range base 4s. That's pretty cool. I mean, I do have a few notes because there's a few things to clean up. But I think that's pretty good. I'm pretty happy. Okay, thanks for stopping by. Have a good one. Ciao for now.